Hello, a pleasant day to everyone, and for this time we're going to discuss about the different structures of the heart, particularly the different chambers, the different valves that blood needs to pass to from the heart to the different vessels of the human body and back towards the heart. The heart has 4 chambers. So this is the anterior portion, posterior portion, the right side, and the left side. This particularly is the inferior portion of the heart, the apex part of the heart. Your heart sits at the diaphragm, the main structure for respiration, diaphragm. Okay, so there are 4 chambers of the heart, particularly 2 atria and 2 ventricles. This is your right atrium, right ventricle, left atrium, and left ventricle. And we'll discuss about the different chambers. So this is your right atrium. Here you could see the vessels and openings of the superior vena cava, draining the superior portion of our body, and the inferior vena cava, draining the abdomen and the different structures, the thighs, legs, and feet. Blood from these areas back to the heart. Okay, superior vena cava and inferior vena cava, draining blood back towards the right atrium. So if we would open the right atrium, okay, so you could see here the different cardiac muscles. We call this your pectinate muscles. In between the right atrium and the right ventricle, the valve there is your tricuspid valve. Okay, tricuspid because it has 3 valves. Okay, 3 valves here. Tricuspid valve. During the fetal life, there's an opening, a foramen that is located between the right atrium and the left atrium. We call that your fossa or foramen ovale. Okay, when the fetus or the baby is delivered, the opening is closed, and we call this one. At fetal life, this is open. Fetal life, we call this your foramen ovale. Since this is closed, we call now this one your fossa ovalis. This portion is still part of your right atrium. We call this your right auricle. Auricle because it looks like an ear-like structure. And the purpose of this auricle serves as a extra room for more volume of the heart. In instances wherein the human being needs more oxygen or the oxygen demand is increased, that means that the heart needs to pump more blood, more volume, so that it can bring more oxygen to the body. So this portion would be filled with blood, more volume of blood, so the heart can pump eventually more blood towards the right ventricle and towards the other portions of the heart towards the body. Now if we open the next chamber, which is the right ventricle, we could see different structures. Okay, We call this at the ventricles your trabeculae carni. Okay? So the inner portion of your right ventricle, the muscles there are called trabeculae carni. Here you could see your papillary muscles, this one. Papillary muscles, this one, are attached to your string-like structures here. These are your string-like structures. The string-like structures are called your chordae tendineae. The chordae tendineae are attached to the tricuspid valve to keep the valves in place during the contraction and relaxation of your heart. Again, papillary muscle, chordae tendineae. Chordae tendineae are attached to the different valves of your tricuspid valve. Okay, the different cusps of your tricuspid valve. Right atrium, right ventricle. Now, after that, the blood needs to go to the pulmonary artery, which is this one. Pulmonary artery is the artery that brings blood from the heart to the lungs. The valve between the pulmonary artery or pulmonary trunk and the right ventricle is called your pulmonary valve. Okay, so this is the pulmonary valve. This one, this one, this one. Okay, pulmonary valve. If you would be able to observe, the pulmonary valve looks like a crescent-shaped moon. Okay, that's why this is your pulmonary valve belongs to or is also considered your semilunar valve. Okay? Semilunar valve. Now, blood from the right ventricle goes to the pulmonary artery through the pulmonary valve, so that once blood reaches the lungs, okay, blood now would be oxygenated. And after which, blood is returned to the heart. The oxygenated blood goes back to the heart towards your left atrium. Okay? In a posterior view, okay, this is your the left atrium. Blood from the lungs returns to the left atrium of the heart through your pulmonary veins. Okay, 1, 2, 3, and 4. 2 on the left, 2 on the right. Okay. Veins in the body particularly carry blood back to the heart. And usually, the different veins of the body carry deoxygenated blood. But for the pulmonary veins, they carry oxygenated blood from the lungs towards the heart itself. So, when we open the left atrium, okay, we could see and palpate for the fossa ovalis, which is this part over here, this one, which is the foramen ovale during the fetal life. If the right atrium has an auricle, the left atrium also has an auricle, left auricle. It serves also as an extra room for blood to fill it up in times that the heart needs more volume of blood to be pumped to the systemic circulation. This is the the left ventricle. Meaning the left ventricle. Okay. We could see that the walls of your left ventricle here are thicker as compared to the wall of your right ventricle, because your left ventricle needs more force to pump blood towards the aorta to the systemic circulation. And we could see here the different papillary muscles attached to the chordate and tendinae string-like structures to the bicuspid valve or mitral valve between the left atrium and the left ventricle. Now, blood from the left ventricle is pumped towards the aorta. This is the aorta, through the aortic valve. So this is the aorta and the opening, and this is the aortic valve. Your aortic valve is also called your one of the semilunar valves because it looks like a crescent-shaped moon. Okay? So when we say semilunar valves, it pertains to the aortic valve with your pulmonary valve. The atrioventricular valves include your tricuspid valve and your mitral valve. Okay? Because they are located in between the atrium and the ventricle. At the right atrioventricular valve is your tricuspid valve. The left atrioventricular valve is your mitral or bicuspid valve. So this is your aorta, which brings blood towards the systemic circulation. Aorta, pulmonary artery. So this is your heart with the different chambers of the heart. Branches of your aorta includes your coronary arteries. You have a right coronary artery, this one, and a left coronary artery. These arteries bring oxygenated blood to supply the heart itself. If these arteries are blocked, this can cause ischemia of the mitral tissues, leading to the death of the tissues. Okay? Your left coronary artery has different branches, okay, including this one here, which goes to the anterior portion of your heart. This one is your anterior interventricular artery. Why interventricular? Inter means in between the two ventricles. Anterior interventricular artery, or also called as your left anterior descending artery. It also has a branch called your left marginal artery and left circumflex artery. Your right side, particularly your right coronary artery, this one, has a branch going towards the posterior portion of your heart, this one. This is your posterior interventricular artery. It's an artery that is a branch of your right coronary artery, which is located in between the two ventricles located posteriorly or behind the heart. So this is your posterior interventricular artery. Now the different veins that drain the heart, okay, converge to a coronary sinus, which is this one. The coronary sinus, okay, drains the different portions of the heart back towards the right atrium. Okay? So this is the opening of your coronary sinus. Coronary sinus, okay, will drain the different parts of the heart through the coronary veins back towards the right atrium. So these are the different chambers of the heart that are used during the contraction and relaxation of the heart. Contraction, systolic phase. Relaxation, diastolic phase. Thank you.